635 light years away from Earth, there's a world covered in liquid ocean. A world where you wouldn't die a horrible death. Probably. Welcome to Kepler 22b.
Hey y'all, I've got an exciting mission to land on and explore a planet that could be Earth 2.0. What if guy got tired of sending me to die in the solar system, so this time I'm traveling to an exoplanet where I might actually have a chance to survive. Exoplanets are like planets in our solar system, except they orbit different stars. They're cool, but there's just one problem. Exoplanets are really far away. So your solar system is this tiny little neighborhood with planets and moons orbiting around a sun in its center. And potentially, light years away, there are billions of other tiny little neighborhoods left to be explored. Now, you might have heard of the exoplanet that I'm going to. It's called Kepler 22b. It's not that far. Okay, only 635 light years. I'll be there in no time.
Even with advanced propulsion technology, a spacecraft traveling at 20% of the speed of light would require 3,175 Earth years to reach Kepler 22b.
Buzzkill. Well, luckily, I'm at a spaceport, and they have this, warp drive technology. So I'll be there in a jiff.
The warp drive technology allows a spaceship to travel faster than light by bending space-time. The warp drive creates a bubble around the ship, moving it through space safely, 99.7% of the time.
Yeah, Rico, technobabble, blah, blah, blah. Never tell me the odds, kid. Let's do this. Well, hello, Kepler.
The Kepler 22 star system is a lot simpler than our solar system. It's only got one exoplanet in it. But this exoplanet, named Kepler 22b, is intriguing. It orbits within the star's habitable zone. And that means one important thing.
Alien civilization.
Water. It means water.
Oh.
Whenever a planet is in the habitable zone of its star, it means that the temperature is warm enough for water to remain in a liquid state, instead of evaporating, like it would, say, on Venus, or freezing like it would on Mars. And the Kepler 22 star is almost exactly like our Sun. It's a slightly smaller G-type star, which means it has a surface temperature of around 5,500 Kelvin. That's 5,200 degrees Celsius. Not too bad for a distant star system, except one thing. This exoplanet, Kepler 22b, is a lot bigger than Earth.
I don't see how that's a problem. It's just more surface to love. I mean, sure, it might have stronger gravity or, like, earthquakes. Kepler quakes? But, like, Earth has earthquakes too, and it's doing just fine.
The larger size of the exoplanet might indicate the presence of a thick atmosphere, leading to high surface pressure. This could result in water existing in a supercritical state, neither a true liquid nor gas, making it less suitable for life as we know it.
It's true, scientists think Kepler 22b might be covered with a liquid ocean, but they can't be sure what that ocean is like. Your mission is to land down there and test the water and the atmosphere.
Yeah, I was just gonna, land. So, here goes the landing sequence. Oh. been almost an hour, and all I see is water. Water! Everywhere water! I think I can land here. Seriously, Kepler, you are one disappointing exoplanet. Give up, Rico. Wake me up if you see any land.
My sensors read land right below us. You are cleared for landing.
Seriously? I can't even take a nap. Okay, let's land. Whoa, this atmosphere is thick! Rico, give me some stats on this planet.
Kepler 22b is a super-Earth, 2.1 times larger and 9.1 times more massive than Earth. It has an orbital period of 289.9 Earth days. It also has water.
Oh, does it? Does it have water? Oh God, thank you so much, Rico. You know, the atmosphere actually kind of looks breathable too. You know, this started out super annoying, but this is actually kind of cool.
Analyzing Kepler 22b atmosphere.
You do that. I'm gonna go see what's out there. Interesting. That feels nice. I can go skinny dipping in here.
That would violate YouTube's terms of service.
Not if it's a music video, technically. Ooh, Rico, what's the temperature out here? I'm starting to feel like some warm bread in a toaster. Toasty.
The equilibrium temperature on Kepler 22b is estimated to be 22 degrees Celsius. However, my sensors pick up a much higher surface temperature.
If Kepler 22b has a thick atmosphere, it would cover the planet like a blanket, heating it up and turning it into an exoplanetary Venus. If the temperature becomes too high, all the water will turn into vapor and Kepler 22b will stop being a habitable world. On the other hand, if Kepler has no atmosphere, well, it might become a frozen world. It would be incredibly cold at night because with no atmosphere, there would be nothing to retain the heat from the day.
That sounds just like Mercury. Not my favorite planet. My favorite planet is Uranus. Kepler 22b, it seems okay. It's a little tough to walk here.
The surface gravity on Kepler 22b is approximately 2.07 times the gravity of Earth.
Yeah, thanks. I noticed that one, Rico. Hey, have you analyzed the atmosphere yet?
Analysis in process.
Oh, so the answer was no. You're still okay.
The thick atmosphere of Kepler 22b likely contains high levels of hydrogen and helium. Those are two gases that are common on larger planets. But if there isn't any oxygen in the atmosphere, you wouldn't be able to breathe. What you should also worry about is the water. It could be acidic or contaminated with toxic elements like heavy metals. Exposure to the body could prove fatal.
Great. So, there's water on Kepler 22b, not that I can drink it, and the atmosphere's in place, and the temperature's all right. What am I missing? Where's all the life?
If life exists on Kepler, it might be microbial. You wouldn't be able to see it without special equipment.
Did you hear that?
My scans are not picking up any life forms.
I gotta check this out. I just need a break first. Oh, this Walking around, that makes me sore. I gotta sit down for a second. I just need to catch my breath.
The atmosphere analysis is not complete.
It's okay. 1 second's not gonna kill me.
Analysis complete.
Something's wrong.
The atmosphere caused your lungs to collapse as a result of barotrauma.
Okay. Thank you.
It looks like the sudden increase in pressure forced the air in Chase's lungs to compress and rupture. One internal organ failure after another, and just like that, he's gone. But don't worry, he'll show up for his next adventure. Well, that's a story for another What If.